Hello, everyone. It is now time to enter into the wonderful world, excuse me, of stoichiometry, one of the strangest words you'll ever hear. We're temporarily visited by this wonderful little gray toad with yellow dots. My daughter made this for me. It's adorable, isn't it? He has to go. Get out of the way, toad. Oh, hedgehog. Thank you, Miranda, for the hedgehog, but hedgehog needs to take a back seat temporarily. What the heck is stoichiometry? Well, it's a lot like making sandwiches. Sort of. Yes and no. Maybe yes, maybe no. Let me explain. Here, ladies and gentlemen, is a recipe for a sandwich. Now, I know sandwiches don't usually have recipes, right? You just kind of throw some ingredients on the bread and you slap it together and you eat it and you enjoy it. But just for sake of example, we'll pretend that this is a legitimate and realistic recipe for a sandwich. 2 pieces of bread, 3 pieces of ham, 1 piece of cheese. Debatable. Some of you would put 12. Uh, put those 3 things together and you will get one sandwich. Hooray. I did leave out the word pieces of, but I did that just for brevity's sake for these 3 things here. So there you go. So if you wanted to create one sandwich, these are the ingredients you would gather and you would combine them in that wonderful special way, and bam, you get yourself a sandwich. Now, we all know that a recipe is not limited to exactly what's written in it because sometimes one sandwich is enough, but sometimes you're hungry, you want 2, or maybe you got some friends over and you want to make 3. Well, a recipe such as this is very easy to adjust. Or, in other words, if you know that you want to make 2 sandwiches, it's easy to determine how many other ingredients you would need. So, for example, let's say you do want 2 sandwiches. Okay, well, 2 is twice as big as 1. Therefore, all of the other ingredients, you would have to double them as well. So, you would need, for 2 sandwiches, you would need 2 pieces of cheese, 6 pieces of ham, and 4 pieces of bread. Hooray! What if you were just wanted a little snack and you wanted a half of a sandwich? That is a thing, by the way. What sort of ingredients would you need? Well, okay, so you would need a half a piece of cheese, 1 1/2 pieces of ham, and but 1 simple slice of bread. So 1/2 relates to 1 and all the same way. So this number divided by 2 became that number. I did the same to all these other ones. Let me make my fancy thing there. Now let's say, oh, something's in the way there. Let me move that. Sorry about that. A little technical glitch there. Now let's say, for sake of argument here, you had 4 pieces of bread. Exactly. No. I did that already. Let's say you have 6 pieces of bread in your bag, right? Your bag of bread. All right. And let's say you had plenty of ham and plenty of cheese, lots of that to go around, but you were limited to only 6 pieces of bread. You could then predict how many sandwiches could be made, and you would predict how much of the other ingredients would be needed. Okay? So the normal recipe calls for 2 pieces of bread. Well, we got 6 pieces of bread. That's 3 times greater. So that means we'll be able to make 3 sandwiches. We will require 3 pieces of cheese. And how many bits of ham there? That's right, 9. So there you go. With a little bit of simple mathematical logic, anybody could take this recipe and kind of rescale it to other quantities, whether that be the amount of sandwiches you want to make, or the amount of cheese available, or the amount of ham, or the amount of bread. It does not matter. Stoichiometry utilizes basically the same sort of mathematical logic, except, where is that other piece? Here it is. It does the same thing with a balanced chemical equation. Yes, I wrote the recipe for the sandwich to look a lot like a balanced chemical equation. And so how does that turn into this? Well, let's start by looking at this balanced chemical equation. C3H8 is called propane. That's right. This is the stuff that you use in your gas grill if you're barbecuing and you don't keep it real. Propane reacts with oxygen, good friend O2, to produce carbon dioxide and water. And each of these compounds has a subscript in front of it, a coefficient in front of it, 1, 5, 3, and 4. And what do those coefficients mean? Well, here's what they mean. This really means 1 mole of propane. That really means 5 moles of water. That means 3 moles of carbon dioxide. And this means 4 moles of water. The word moles doesn't appear next to these numbers here, but it's implied. That's right. That's one thing you must understand from this video and take away is that when you read a balanced chemical equation and you're looking at numbers or coefficients rather in front of a formula, that number means moles of that substance. 1 mole of propane, 5 moles of oxygen, 3 moles of carbon dioxide, 4 moles of water. Do the claps make it any better? I didn't think so. I thought it was worth a try. People do that on Twitter all the time. They put a clap between every word because that's supposed to make you believe what they say. Anyway, in the way that I kind of adjusted the recipe or scaled up or scaled down the recipe for a sandwich, so too could this happen. For example, let's say, this is a silly question, but let's use it anyway. Let's say that your gas tank has exactly 2 moles of propane in it. If those 2 moles of propane were to burn, how many moles of oxygen would burn with it? That's easy. 2 is twice as big as 1, so we want to look for something that's twice as big as 10, or 5 rather, and that would be, 10. So 10 moles of oxygen would burn with the 2 moles of propane. How much carbon dioxide would be produced? Oh, that's also easy. That would be 6 moles of carbon dioxide. And water? Oh, easy. 8 moles of water. So on and so forth. What I did for this example here is I simply doubled the amount of propane and then predicted how much of the other compounds would be involved simply by doubling them as well, keeping everything in proportion or ratio. Up till now, all the examples that I've done, both with the sandwich and both with the propane, have actually been quite simple. Okay? But what if you get a situation like this? What if you were to get, let's say I was to ask you, all right, let's begin with 0.154 moles of propane. How much oxygen would react with that? How much carbon dioxide would be produced? How much water would be produced? Well, the prediction of that is not quite so easy. The mathematics of turning 1 into 1.54 is not something that most people can just do in their heads. Okay? And so, in the next video, I'm going to show you a surefire, reproducible, and reliable mathematical technique that will allow you to solve basic stoichiometry problems like this one that involve numbers that are not quite so easy to just kind of work out in your head. So please go watch the second video and hold on to your hats because it could be a little tricky at first, but with practice, you'll get used to it. And